Welcome to section 6.5 of Algebra 2, Solving Radical Equations. And here is your daily joke. Who invented algebra? Are you ready? How about a clever expert? So our focus for this lesson today is to solve radical equations. Now I know what you're thinking. You're probably asking yourself, what is a radical equation? And simply put, a radical equation is an equation that has a variable in the radicand. Oops. Okay, now there are four steps, basically, when solving radical or rational equations that you need to keep in mind. And you already have these on your notes. Number 1, isolate the radical or the rational expression. And we do that by adding or dividing constant terms to the other side. Number 2, we're going to raise both sides to the reciprocal power. 3, we then can solve for the variable. And 4, be sure to check solutions that were raised to even powers. That is very important. You need to circle that or highlight that, because what's going to happen there is you could have extraneous solutions. And extraneous solutions are solutions that do not make the original equation true. You can solve for it, you can get like x equals 6, but when you go to plug it back in, it will not make a true statement. And that is an extraneous solution. And again, those occur when you raise both sides of an equation to even powers. Okay, so now let's take those 4 steps and apply them. So we have the radical equation, 3 plus the square root of 2x minus 3 equals 8. Now step 1 says to isolate the radical expression. And to do that, your first thing you're going to have to do is get rid of the 3. Well, the 3 is positive on the right, so to get rid of it, we're going to subtract it. Bring it to the left side. So I now have the square root of 2x minus 3 equals 5. And now I got to get rid of that square root. Step 2 says raise both sides to the reciprocal exponent. Well, to get rid of a square root, that simply means you square it. Square rooting and squaring are inverse operations. So I'm going to raise both sides to an even power. So on the left-hand side, I now have 2x minus 3 equals 25. And I can solve this linear equation just like I have in the past. I'm going to add 3 over, and I'm going to divide by 2. But if you remember from the previous slide, step 4 said be sure to check solutions that were raised to even powers. And we raised our equation to an even power in the first step, or in the second step right there. So we need to make sure that 14 is a valid answer. So to do that, we plug it back into the original equation, and we just check. So I have 3 plus the square root of 2 times 14 minus 3, and I want to see, is that equal to 8? Well, let's start with their inside. 2 times 14 is 28. So I have 28 minus 3 underneath the radical, and that's going to be 25. So this is really 3 plus the square root of 25. And again, that is 5. So 3 plus 5, do I get 8? Yes, I do. That one works out. Okay, so let's try example number 2. Now this is the square root of 4x plus 1 plus 5 equals 0. And we want to go ahead and try to solve this one. So again, we want to isolate the radical, which is this term right here, which means we have to get rid of the 5. So I'm going to move it over to the other side. This gives me the square root of 4x plus 1 equals negative 5. And how do we get rid of a square root? We square both sides. But be careful, because I'm now raising both sides to an even power, so we will have to check our answer here at the end. Well, the square root of 4x plus 1 squared is just going to give us 4x plus 1. And negative 5 squared is 25. Again, this is now just a regular linear equation. So I'm going to get rid of my 1, and then I'm going to divide by 4, and I get 6. Alright, let's check our answer. So this is the square root of 4 times 6 plus 1 plus 5. And I want to know, is this going to equal 0? Well, 4 times 6 is 24, plus 1 is 25. So I have the square root of 25 plus 5. Square root of 25 is 5. I only want the principal square root. 5 plus 5 is 10. So it is not equal to 0. Therefore, this solution, x equals 6, is an extraneous solution. And we have no valid solution. And that's all we write. The problem is now done. Another way to think of it, that there is nothing that I can multiply by 4, add 1 and take the square root of it, add 5 to equal 0. Okay, for example 3, we're going to mix it up a little bit. We're not going to have a radical equation, we're going to have a rational equation. And we treat it the same way. We can still go ahead and we solve for it just like we would with a radical equation. The first step, isolate the rational term. Well, that's already isolated. There's nothing that's adding or subtracting to it. Step 2 then says raise both sides to the reciprocal exponent. Well, the exponent that I have is a 2/3 power. So the reciprocal of 2/3 is 3/2. What I'm going to do then is I'm going to raise both sides to the 3/2 power. Okay, now think about your exponential rules. What happens when you have powers raised to powers, like we do here? Well, we multiply them together. And 2/3 times 3/2 is really 6/6, which is simply 1. By multiplying it or raising it to the reciprocal power, you will always end up with just a 1 exponent, or something to the first power. So I'm left on the left-hand side with x plus 4. Now the right-hand side we can simplify, because we have 4 raised to the 3/2 power. Well, my denominator is 2. That's really asking me, what is the square root of 2? Now you may want to think back to radical form. 4 to the 3/2 is really the square root of 4 cubed. And the square root of 4 is 2, and I have 2 cubed. 2 cubed is 8. Alright, and so when I solve for x, I get 4. Now because we did not raise both sides to an even power, we don't necessarily have to check your answer. You should not have extraneous solutions in this case, but it's always a good idea to check just to make sure you did not make an error. Okay, number 4. We have the square root of x plus 7 minus 5 equals x. So I'm going to solve for the square root of x, that term right there. And again, I want to go through my steps, meaning I have to isolate it. So I move the 5 over to the other side. Well, now I have the square root of x plus 7 equals x plus 5. And I still try to get rid of that square root, so I'm going to square both sides. Well, on the left-hand side then, that's pretty easy. I'm just left with x plus 7. But on the right-hand side, remember x plus 5 quantity squared is really x plus 5 times x plus 5. You're going to have to FOIL that out. Or if you remember your shortcut, that's what I'll use here, you can use that as well. If I have a quantity squared, I simply square my first term, multiply my two terms together, and then I need to double that, so I'm going to show that by taking it times 2, and then I square my last term. So this is really x plus 7 equals x squared plus 10x plus 25. Alright, you may notice that you have a quadratic here, which means to solve a quadratic you want to set it equal to 0. we're going to look to see if we can factor it or if we have to use a quadratic formula. So I'm going to subtract the x over and subtract the 7. This is going to give me 0 equals x squared plus 9x plus 18. Alright, so my a value is 1. That means I want to find factors of 18 that if I multiply them together I will get 9. Hopefully you are all thinking, well, 3 and 6. 3 times 6 is 18. 3 plus 6 is 9. So this problem does factor. And when we solve, we get x equals -3 and x equals -6. But I did raise both sides to an even power, so I do need to check my answer. And it has to be back in the original. So I have the square root. I'm going to check -3 first, by the way. -3 plus 7 minus 5. And I want to check that I get -3 as my answer. Well, this is the square root of 4. Square root of 4 is 2. 2 minus 5. I do get -3. That one works. Okay, now let's check -6. I have the square root of -6 plus 7 minus 5. Is that going to equal -6? And -6 plus 7 is the square root of 1, which is just 1. So I have 1 minus 5, which is -4. And we all know -4 does not equal -6. So in this case, -3 is a valid answer, but -6 is not valid. It's extraneous. So we actually need to just discard the -6. Okay, last problem. Number 5. We want to solve the equation, the square root of 5x minus 1 plus 3 equals x. We're going to go ahead and start it now, and I want you to finish it. So the first thing I need to do is isolate my radical term. So, in other words, get rid of the 3. Okay, now I need to get rid of that radical sign. So you're probably thinking we need to square both sides. Okay, I did that, but I want you to finish it. Show me the answer tomorrow, and good luck.